Hi, my name is Austin Nimchek, and I'm going to be talking about climate change. Now, everybody knows what climate change is and what it entails, but a lot of people still doubt it and think that it's just political propaganda to help the government make money and sell innovations. Now, I'm not going to try to convince you or change your mind, but I'm just want to give you the facts and help you make your own decision. Now, to understand climate change, we need to know the who, what, when, and where. And just like most innovations or new theories, not one person alone stumbled upon it. It was discovered over a long period of time by a lot of people. Now, Spencer Ware, who is a noted historian and who specializes in modern physics and geophysics, says it best. He says, the basic physics of climate change have been known for more than a century, but it is in recent decades that the fundamental science of global warming has solidified. Now, climate change was theorized as early as the ancient Greeks as they debated the effects of cutting down their trees and what it might do to their rainfall. Now, in 1896, savant Arrhenius theorized that the burning of fossil fuels and CO2 emissions would raise global temperatures. Now, it took until the 1930s for him to be proven right, when it was discovered that the North Atlantic region had warmed significantly in the last half century. And people immediately thought that this was a good thing because warmer temperatures would make life easier. A huge blow to climate change was actually the discovery of Earth's ice ages and the fluctuation of global temperatures in the past. It caused a lot of people to doubt climate change and a lot of people to believe that today's warming was just due to the warming side, being on the warming side of past ice age, and that the temperatures would begin to rise eventually in the future and begin a new ice age. Now, Earth's warming today is completely different than the past. And the way we know this is due to the data collected from tree rings, glacier ice layers, and ocean sediments. Using this, scientists can look back 800,000 years and determine the average global temperatures in that time. This information collected is called paleoclimates. Now, these paleoclimates allow scientists to see times that were actually warmer than they are today, but it also shows that those times got warmer over a very long period of time. Now, according to NASA's Earth Observatory, past temps rose 5 to 7 degrees Celsius over a 5,000 year span. Now, that's compared to today's 0.7 degrees Celsius in the last century. Now, that's 10 times faster than the past. Now, Earth does have a natural cycle that allows temperatures to drop and raise again. As the global temperatures drop and they warm, CO2 emissions are released into the atmosphere through volcanic eruptions and ocean vents and ice melt. But plants actually absorb that CO2 and allow the temperatures to rise again. Plants absorb up to 8.8 billion tons of CO2 emissions every year. They're considered Earth's greenhouse sponge. Now, you might ask, well, what's the worry? Why don't we just let plants, or even plant more plants, to help absorb some of that CO2 so we don't have climate change? Well, according to Scientific American, as of 2017, the Earth's global emissions were as high as 40 billion tons a year. Now, that's also equal to a 40 million square kilometer forest fire, or as equal to a forest fire consuming the entire continents of US and Africa. Now, that's far more than the 8.8 billion that the plants can absorb, and that's not including deforestation. So we know what's happening, but now we need to know how we can fix it. One of the most plausible ways is nuclear energy. A new theory or a new design for nuclear energy is molten salt as a coolant. Now, in past designs, you use ocean water to cool the nuclear reactor. The problem with that is what happened is an example of Fukushima. When the tsunami hit, it caused an issue where the seawater wasn't able to get to the reactor, and the reactor superheated and went to meltdown. But with the molten salt, it's not going to evaporate, so there's no need for a constant flow of that salt. so you would never have the issue of having a meltdown. Now this allows it to be cheaper because there's less maintenance, also safer because you're not going to have meltdowns, so there's no radiation and there's no nuclear waste. But it's not going to be even possible or reality until at least 2030. But I think we should still strive for that to try to help us lower our emission and carbon footprint. Another way is through solar and wind energy. And if we follow Iowa and California, who lead the nation in solar and wind energy, we'd have a good chance at really reducing our carbon footprint. But the issue with solar and wind is it's not always windy and it's not always sunny. Now our batteries can hold some of that energy, but not enough to power an entire city. So we would need to design newer, better batteries. But the batteries are also super expensive, and the resources are very limited. Now, plants and factories are also the US's #1 emission contributors. According to the EPA, 50% of US emissions come from factories and electricity production. A new design is called carbon capture. Now, this carbon capture technology can reduce these emissions straight from the factories. ExxonMobil is the #1 in this area. They're up to 73% of their CO2 emissions are captured by this system and stored underground. Well, that's my speech on climate change. Thank you very much for listening, and I hope you learned something. If not, I hope you're inclined to go do your own research and make your own decision on climate change. Thank you very much.